Hey Mom, hey Dad.
Hey Billy, what's up?
Hey, Billy.
How was school today?
What? No, nobody's... It was fine.
So what'd you do today?
Well, Mr. Sauter taught us about quadrilateral proofs today.
So, can you show me what he taught you?
Sure, let's go inside because I'm cold as...
So, tell me about quadrilateral proofs.
Well, let me just put it this way. They're rectangles and rhombuses, squares are parallelograms, subsets and isosceles. They're all quadrilaterals versus parallelograms. Opposite sides are parallel. They are also congruent. The angles are congruent too.
Consecutive.
Angles supplementary.
Diagonals.
Bisect each other.
This also goes for
All the quadrilaterals.
except trapezoids.
Trapezoids are pretty weird. They have just one pair of parallel sides and safe and supplementary angles. Now, isosceles, trapezoids different from the other. Same rules as the trapezoid, diagonals are congruent. Legs measure the same length. Areas equal b1 plus b2 times height divided by 2. And now we move on to the rhombus, different from the trapezoids. All sides are the same diagonals with the 4 angles. Perpendicular lines. Then we move on to the rectangular shape. Diagonals are congruent. They only have 4 right angles. That's all there is for rectangles with the parallelograms. Now we move on to the square, which is very unique rules. Take them from the rectangles and the parallelograms and the rhombus, but not the trapezoids. I told you they were pretty weird. So all the quadrilaterals have their own properties. They are the basis for quadrilateral proofs. Now you know the rules to do all the proofs. Don't forget the song, the Ken Ken song. So, we can prove the diagonals bisect each other by doing the midpoint formula. Now, since they share the same midpoint, we know that the diagonals bisect each other and it's a parallelogram.
So we know that JKLM is a parallelogram. JM equals LM, and angle LMN equals LNM. Since these two base angles are equal, that means that it's an isosceles triangle. So since we know that LMN is an isosceles triangle, we also know that LM equals LN because an isosceles triangle has 2 congruent sides. Now, since we know that LN equals LM, we now know that LM equals JN because of the substitution postulate. So now that we know the substitution postulate and these 3 angles are equal, with a parallelogram, we know that opposite sides are equal. So JM would equal KL, and LM would equal KJ. That the substitution postulate taught us these 4 sides are equal. We know that in a rhombus, all 4 sides are equal. So this would make KLJM a rhombus, which is what we're trying to prove. Here you go. KLJM is a rhombus because all sides of a rhombus are congruent. So we know that angle ADG is congruent to angle BCG, and ABCD is a rectangle. To prove that AE equals BF, first we have to know rules of a rectangle. Since opposite sides of a rectangle are equal, AD would equal BC. Now, another rule of a rectangle. Since a rectangle has 4 congruent sides,
angles.
we know that angle A and angle B are right angles. And since A and B are right angles, we know that all right angles are congruent, which would make A equal B. So, since these 2 angles are equal, these 2 sides are equal, and these 2 right angles are equal, that would make triangle ADF equal triangle BCE. So, after angle side angle, we would know that AF equals BE because corresponding parts of corresponding triangles are congruent. So for the 7th step, these 2 triangles share this, EF. So that would make EF equal EF because it's reflexive. For our last step of this proof, we can find AE being congruent to FB using the subtraction postulate because AF minus EF would be congruent to BE minus EF.